everybody, and good morning or good afternoon. Today we will be talking about coastal food innovations and livelihoods. We have multiple speakers from Wageningen University and from Indonesia. And yeah, let's see, where is my presentation? Can the managers put my presentation on, please? Or do I have to do that myself? Yes, great. So yeah, we want to talk about how to establish a farm-to-fork practices using low-trophic aquaculture. So we'll be talking about seaweed, about mangrove restoration, and about mussel cultivation. And yeah, we will give a short overview of the different projects we have. And after the short overview, we will move out into breakout sessions with each of the speakers. And there, the audience can talk with the speakers in a smaller setting for 15 minutes. After 15 minutes, we will change up and you can go to another breakout room if you want. And then we have another 15 minutes to talk about the different projects. And then we come back into this main room and we have a discussion about what we all discussed, what you learned, what kind of insights you found, and maybe new collaborations. So yes, let's get started with the list of our speakers. So first we have my colleague, Dr. Pepijn van Oort from Wageningen Plant Research. He will be talking about, he will be talking about the project bioeconomic seaweed model, and he does this in collaboration with Dr. Rukmina Sari from Indonesia. After Pepijn, Dr. Nita Rukminasari herself will talk. She is from University of Hasanuddin, and she will talk about searching for high protein in seaweed. Then we have my colleague Sander van den Burg from Wageningen Economic Research, and he has a presentation about how we should rethink the use and production of seaweed. After which we have a small presentation from Professor Sri Rejeki from the University of Diponegoro in Indonesia, and she will talk about using green mussels for mangrove restoration. Then we have our PhD student Iftakaru Alam from Bangladesh to talk about the synergistic effects of mangrove leaf litter on shrimp. And last but not least, my colleague Dolphy de Brot from Wageningen Marine Research, and he will talk about the key challenge in mangrove restoration. So yes, let's get started with our first presentation of Dr. Pepijn. Pepijn, the floor is yours.
2 slides, right? So you can show them. Romy, would you show the next slide? Yes, okay. We have visited some seaweed farms in Sulawesi and talked with the farmers and also with other partners in the supply chain, so the collectors and the processors. And what we heard from all these farmers is they harvest their crop, they have many lines in the water, they harvest a line after 45 days. When after harvesting, they replant, they separate the seaweed into a part that is replanted and a part that is dried and then sold to the traders. And it raises a question on how long should we keep the seaweed growing? Is it better to keep it, is 45 days the best? That is what everybody thinks. Or is it better to let it grow for a longer time, or maybe let it grow for a shorter time and have many more harvests? So this made us develop the model which you are seeing here, and this is just an idea in our head of how we think the growth cycle works. We have a whole year in which you can have cycles of, for example, 15 days or 45 days or 120 days. If you have 120 days, you will have 3 harvests per year. If you have 45 days, you will have 8 harvests per year, and so forth. And so we can calculate the net annual production. So that is the product that is actually sold to the traders. We can calculate this for these different options. And you can see in the table below some indicative figures showing what might be best. So we can see here in this example calculation that with shorter cycles you might have slightly higher production, and long cycles are not so good. And that is because, as you can see in the solid black lines here, after a while the production flattens off. Can we see the next slide, Romy? Okay, another important question that farmers face is how much of the harvest should be replanted. And let me take you to the bottom green line, which is starting with a very low start weight. So they are maybe selling 90% of their harvest and using 10% for replanting. And then what you will get is the green curve with a low initial start weight, and then you have a very slow initial growth. Whereas if you go to the orange curve, we can see if we sell, for example, 70% and we replant 30%, then we start with a higher initial weight. And so the initial growth rate will be a lot higher. And then actually, even though you are replanting, even though you are selling only 70%, the growth is so much higher that in the end, this is still better for the farmer than starting with a very low initial weight. And then lastly, if you replant 90%, then you start with very big seaweeds in the seed, which in the sea, that's the blue curve. You start with very big seaweeds in the sea, which are growing only very little. So then that's economically also not so good. So in the end, what we are doing with our model is we think you can do some, we can have an understanding of how the cultivation system works. And we can see that this model can help us search for what is the optimum cultivation period. Is it 45 days, or is it shorter, or is it longer? But we should consider this in combination with which percentage of our harvests are we replanting and which percentage are we selling. And this is our idea, which we are presenting here in these figures. It's nice to have ideas, but in the end, we want to know if this, we want to measure things and test our ideas in practice. So that is why we are doing an experiment, which is together with UNHAS, with Dr. Anita, who is also in this presenting after me. Can we see the next slide? Now, please, can we see the next slide? Thank you. So here you see a Google Earth image. We see in the top right a river which is flowing into the sea, and we can clearly see here the fields, the plots where seaweed is growing. So farmers are actually growing seaweed over here. And we planted 6 lines at these 6 locations, which you can see they are closer to the river and further away from the river, and closer to the shore and further away to the shore. And on each of these locations, we have seaweed planted. And on each of these locations, we are doing weekly sampling to determine the water quality and the seaweed biomass. And then with that, we hope to estimate the parameters for the growth curve and to validate our model. That is it. Thank you for your interest, and if you have any questions, I'll be happy to answer them.
Thank you, Pepijn. Questions will be done during the breakout sessions, so then we can talk about more in depth in your project. Thank you so much. So we will go to the next short presentation from your colleague who you work together on this project with, Dr. Nita Rukmasari. Can we go to the next slide, please?
First slide, please. Okay, thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, good morning, everybody. First of all, I would like to send my gratitude for winner organizing committee who give me an opportunity to present our work in this very valuable workshop. The title of my presentation is Searching a High Protein Content of Seaweed Species from the Eastern Indonesian Waters. This study is collaboration between Kalbe Pharma, Unhas, and Center of Excellent Development and Utilization of Seaweed. Next, please. Next slide, please. Okay. As we know that there is a high demand of protein globally, and then based on the food agriculture organization mentioned that 70% source of protein came from terrestrial source, which is required a high area of land and energy usage. On the other hand, there is a high potential protein source from the sea, and Indonesia has a largest coastal area with the approximately 8,000 kilometer coastline. And Indonesia also has a high diversity of seaweed species. And we know Indonesia is the first seaweed producer in the world. So we already know that there are 3 or 4 economic value of seaweed has already been cultivated in Indonesia, which is Glaciolaria, Capapicus, Kemakatoni, and Gilidium. And then there are a high protein content seaweed species that could be found in Indonesia, which is Porphyra. It's approximately 44% dry weight of protein. Glaciolaria changi, 34% of dry weight protein. Gilidelia acerosa, 31.1% of dry weight protein, and etc. And the demand of a nori product is high, and at the moment, Japan and South Korea are the main countries which produce nori. Based on this fact, it is a high potential for developing a high protein content of seaweed product, especially nori. Ladies and gentlemen, in the objective of this, next slide, please. The objective of this study are to search a high protein content of seaweed species from eastern Indonesian water, and to examine the cultivation technique for selected high protein content of seaweed species. We focus on Porphyra sp, and then to develop a method for producing a high protein of seaweed product or nori. Next slide, please. The study was conducted at several locations, Bira and Selayar Island, Bone Regency, Mamuju, West Sulawesi, Bitung, Ambon, Lombok, and Bali. Next slide, please. Okay, the result after we exploring several locations, From the location of study, Porphyra only found at Ambon. It's only particular months during July to September. And then the other 5 locations, Bira, Selayar, Bone, Mamuju, and Bitung, we didn't found any Porphyra sp. The ongoing exploration will be conducted at Bali and Lombok to search Porphyra. Why is Porphyra? Because Porphyra is the best material, the best raw material for nori. Okay, so we also have conducted a cultivation trial for Porphyra using the seed from Ambon, and we found that there is a good growing Porphyra at laboratory scale. Next, please. Next slide. What is the next step? The next step, we will conduct a more exploration in a wide area of eastern Indonesian waters, Bali and Lombok, and also Papua, to find Porphyra. And then also we will conduct more experiments for finding a better method or technique for cultivating Porphyra, and also we will conduct a trial for producing a nori from Porphyra. I think that's all about our study. Thank you for your attention.
Thank you, Dr. Rukmasari. Now we will go to my colleague Sander van den Burg, who will talk about the need to rethink how we produce and use seaweeds. Sander? Sander, you are muted.
You can not unmute me. Apologies. Thanks, Romy. Thanks for the introduction, and thanks for the opportunity to present some of our work on the economics and the consumer studies on seaweed. I'll keep it briefly, but I do want to take a somewhat higher level perspective on how we use seaweed and can use seaweed in food systems of the future. So if you move on to the next slide, please. Then what we currently see and what we study in this project is polyculture of seaweeds in ponds. As was discussed before, the red seaweeds that are produced in those ponds are currently used for the production of texturants, and these ponds can be monoculture or polyculture. And some studies have confirmed the potential there is for using these ponds for different kind of species. So there's a significant area allocated to ponds, and not that much is used for polyculture, but more potential is there. Next slide, please. If we look at the potential from an economic perspective, well, some studies have already confirmed that it is interesting from an economic perspective to go for polyculture. There is a study work done by a PhD student at Wageningen who also presents his results at this winter conference, Priadi. So I will not present those results in this presentation, but it shows that the polyculture of tilapia shrimp is economically an interesting alternative for the farmers. At the moment, we are collecting the data for the polyculture of seaweed and mussels, milkfish and shrimp in Java, and we hope to present those results soon. I think above all, from an economic perspective, the question is how can we create more value from the biomass that is produced in these ponds. One avenue to pursue is to do more processing on site rather than export raw materials only, and that would mean you will include various steps of the value chain on location. And the other interesting option is to look at new products and new markets. And let me explore that in a bit more detail on the next slide. If you follow this debate on seaweed and food security a bit, there's some critique on using seaweed for the production of texturants, arguing that does not add much to food security. And I think there's a point there. So much of the seaweed is indeed used for texturants, for jellies, ice cream. Is that really adding much to food security, or is it not? Our consumer research on Java has confirmed that most of the consumers associate seaweed with the sweets and the desserts and the jellies. and only smaller segments of consumers associate seaweed with nori for direct consumption or as a meat replacement. And I think there's potential there. But the studies also confirm that most consumers do not know how to use seaweed in novel ways and do not recognize its potential. I think that's definitely an avenue that we should pursue. Maybe that means we should focus on different species or educate consumers, help them in figuring out how to use seaweed for other applications than the sweets and the jellies. Next slide, please. And already my last one, I think concluding a bit of looking at our studies, I think it's interesting to see how seaweed can be used. At the moment, the cultivation contributes to livelihoods, it generates income to the seaweed farmers, but we are of the opinion that its potential is not fully used at the moment. If we can go for polyculture, our belief is that this will increase the value, increase and generate higher incomes for farmers, also benefit pond performance and the environment, but there's other publications and presentations on that. And we see the potential to develop new products in the food and maybe also in the non-food market that could add more to food security and support farmers in generating more income from these practices. So that's it for me. The next slide's already there. Yeah, there's Dolphy.
No, the next presentation is from Professor Sri Rajeki. Thank you.
Thank you very much for the winner for giving me the opportunity to present my idea. I'm going to talk about the green mussel for mangrove green belt protection, as well as for coastal community income and food safety and food system resilience. Next slide, please. The coastal communities that mostly practice water shrimp and fish farmers in the Demak district in central Java have realized the importance of a protective coastal mangrove green belt after their participation in the Associated Mangrove Aquaculture, or AMA, a program for mangrove restoration organized by Building with Nature Indonesia. The mangrove green belt improves the pond water quality and increases the nutrient and food concentration available in the coastal waters for marine organisms. As a result, the pond farmers' yields are increasing and the artisanal fishermen obtain higher catches. Next slide, please. Ongochoya village is one of the villages in the Demak district that has successfully implemented associated mangrove aquaculture. Many farmers with coastal ponds have dedicated part of their ponds to allow space for mangrove green belts, and this needs to be protected so that they are not damaged or cut down by the local community for firewood or building materials. Because not all of the coastal communities are shrimp farmers nor artisanal fishermen. Some of them do an odd jobs, so that's why we have to provide a job opportunity. One of which is providing this construction for green mussel. This is one way to protect the coastal green belt that is feasible to be done by the local community is using bamboo and rope construction towards the mangroves, and this construction can simultaneously used to culture the native green mussel called Pandaphilidis as a source of income, as convincing financial incentive to maintain the structures. Next slide, please. Then green mussels attach naturally in the bamboo and ropes construction sheath of the mangroves ecosystem, and they grow very well. They're also safe for consumption because mangrove roots are able to absorb pollutants, including heavy metals, and green mussels were previously considered to have a poor economic value. However, since 2018, the green mussel has recorded as a fishery commodity because of their increasing value. Moreover, the green mussel meat and shell are also have a market price. The green mussel price now increasing from 8,000 per kilo in 1918 and now become around 15,000 rupiah per kilo. And the green mussel can be harvested 4 times a year, and this can serve as an effective source of income and livelihood for the coastal community, while also increasing the food system and resilience. Next, please. Next slide. Yeah, so this is my conclusion that green mussel construction, i.e. using bamboo and line, can produce green mussel naturally, which can support the coastal community livelihood and also can create a job for them, for the people who are doing the orchards, and also create a food system, resilience, and also food safety. Thank you very much. Okay, Romy.
Yes, thank you, Bushri. The next presentation will be done by our PhD candidate, Iftikhar.
Thank you, Romy. Greetings from Aquaculture and Fisheries Group, Wageningen University and Research. And also thanks for the winner organizing committee for giving me a chance to present our work. We did many works on mangrove leaf litter and the relation between the shrimp performances. Here is some parts, which is the synergistic effects of mangrove leaf litter and supplemental feed, where we use with feed and without feed experiments, and we found some results which I am going to present now. Next, please. Next, yeah, thank you. We set 2 research questions for these experiments. Does the mangrove leaf litter contribute the production in non-fed or fed shrimp nursery system, that is with feed and without feed? And how do the different common mangrove species affect production in the non-fed and fed nursery system? Here, we used 4 types of mangrove tree leaf litter. If we see that there are 4 in the below, and we selected this based on the performance on the mangrove leaf litter, like with the literature review, and there was a prevalence of the farmers to give their consent as they are practicing shrimp farming, and there are some mangrove trees, and with their preference we choose these 4 types of leaf litter. Next, please. Yes, if you see that without leaf litter, we found that the shrimp peel, there are 100 shrimp peel and all died. They started to die very beginning, and within the next week, all the shrimp died. That's why we think that this shrimp peel died due to the lack of feed. Next, please. Yeah. And if you see this curve, we see that there are 2 graphs in each space. For that is the first on this Sonaresia apitala, without feed and with feed. There is also good survival without feed. If you see, that is around 70 to 80%. And if you see the p-values, that there is a effect of feed here, and there was no interaction effect. But if we see straight, there is a good survival without any kind of supplemental feed. The shrimp was able to survive with leaf litter only. Go next, please. If we see the individual weight, we see that without feed, the growth was low, but when we added 5% feed, we see that the growth was higher. That's why we see that. That's why we call it the synergistic effect, because without feed, the shrimp PL managed to survive, but the growth was not up to the mark. But when we apply some feed, we see that the growth was higher, and there is a clear effect of feed, and there is also a clear effect of interaction, mangrove species feed, if we see the p-values. That's why we call that there is a synergistic effect. If we go to the next slide, we see that if you see the feed conversion ratio, we see that the higher food was applied when with the experiment with only feed, but when there was a leaf litter, we see that for the first one, Sonaracea apitala, lower amount of feed, and for Hericiera forms, there was little bit higher, but with leaf litter, the application of feed was lower for the growth performances. And if we go to the next slide, we have some take-home messages, which are that mangrove leaf litter sources natural foods, and this differs based on the species, because we saw that Sonaracea apitala gave the higher growth performance, followed by cassularis, and the lower was with Hericiera form. That's why there was the effect of species. And if we combined the leaf litter and feed, we found 21 to 30% higher weight gain than based on the contribution of leaf litter alone or feed alone. That's why we told that there is a synergistic effect, and the effect was the 21 to 33%. If we rank the 4 species which we tested in Bangladesh, where this Sylviaca culture is very new, we found that Sonaracea apitala ranked the first one. It gave the highest growth, following by Abyssinia officinalis, Sonaracea cassularis, and the lowest performance of Hericiera forms. If we go to the next, then we find that in our experiment, where I did the experiment in Bangladesh, in the rural area, I engaged some farmers, and they saw that mangrove leaf litter with feed was doing the better. That's why they were motivated to adopt the Sylviaca culture, because it is very important in Bangladesh, as Bangladesh lost many mangrove trees due to shrimp culture. That's why we engaged the farmers, and they are motivated. That was a very good findings from us, and for the best message for the farmers. And we have already 2 publications. If you want to get more information, then there is a 2 address here. You can visit and get some more information on our research. Thank you very much.
Thank you, Iftikhar. And then last but not least, my colleague Dolfi de Brood will talk about the challenge in mangrove restoration. Dolfi?
Thank you very much, Romy. Yes, indeed, as the previous speakers have indicated, several of them, all working on helping to transform food systems in tropical coastal zones to a more sustainable system. This is a major challenge also for mangrove coastlines. And what we often see is that even though farmers, communities, science knows that mangroves are very important, serving many ecosystem functions in tropical areas, coastal protection, nursery value, habitat for wildlife, etc. What you often see is that even when mangroves recover to areas that they have been lost in the past, the mangrove restoration is not sustainable. It happens, but then after a period of time, guess what happens? As you see in this picture, the mangroves are cut down, and the net result of all your efforts of mangrove restoration are again 0. Now, this is a big problem and a big challenge in mangrove restoration. And the question is, why does this happen? Well, one of the key reasons why it happens is that these farmers have no other option. They can understand how important mangroves are, but when it comes down to it, to put bread on the table for their family, and they have no other option, then the mangrove will be chopped, the ponds will be dug, and they will continue in their unsustainable practices. So the big challenge is, how do we develop livelihood opportunities for people living in these mangrove areas? Next slide, please. This slide basically shows you that mangroves have a wild and colorful palette, a diverse palette of opportunities for livelihood development. Briefly running across from left to right down to the bottom, mangroves can be very useful as fodder for goats and sheep, as you see in slide A. You can make delicious fruit juices. You can process them to foods, as in C, teas. They are a very good and productive source of sustainable fuel wood in E. There you see in F, their use as a source of tea. Staple products in G, medicines in H. Here you see school children in Indonesia learning to make the jelly. They're excellent sources of dyes that can be used to make beautiful clothing, as you can also see in K, where school children are learning the old tradition of batik. They are excellent sources of sweets, syrups, and honeys. Down below you see jellies, dried staple products, cakes. In Q you can see how mangrove leaves are even suitable to make chips, very, very tasty chips. Very few people know about this. And also cake from the nipa palm. So there are all these opportunities and all these native uses. Oh, I should also mention P, that goat there. That's a specially adapted small goat that can deal with high salinity in mangrove areas. So you can even have goat production in mangrove areas, whereas most goats are not tolerant to salinity in their diet, and they're too big. You know, this is a small animal that can walk in the mud and survive on very saline diets. So we even have that as an opportunity. So the question is, what is the barrier to actually developing all these different opportunities for livelihood, sustainable livelihoods not being pursued? Next slide, please. So for this, one key answer is that it is likely that we are not looking at the system in an integral fashion, because to have a product that is useful at the subsistence level, in order for people to make a living from that, they need to be able to collect it, process it, market it, and sell it. So you are dependent upon activities and partners in a whole chain along the process of producing a product and selling a good product to consumers. It's very easy to produce a great deal of seaweed, but if nobody eats it, then there's no sense in producing it, and notwithstanding all your beautiful results, the transformation that you're desiring will not take place. Or if you're unable to store the seaweed, the whole value chain will not be able to come into effect. So in Wageningen, the food system approach has been developed, and this is a way of dissecting and analyzing the system so that you can actually see where the knowledge is needed, where research is needed, and where you need to develop certain kinds of technology in order to make these many different possibilities for mangroves and seaweeds and all to actually come to fruition, help the local people, and be the basis for sustainable livelihoods. Next slide, please. Yeah, the key points, I guess, from a lot of the recent mangrove research is that it can only succeed, in other words, sustainable transformation to the use of seaweeds and mangroves and mollusks, etc., can only take place if you develop viable and sustainable livelihood alternatives. If you do not do that, only presenting arguments of how beautiful and how important mangroves are, ultimately the people will have no alternative other than to cut them down. That second slide of mine showed a few of the 203 possibilities for livelihoods from mangroves in the Asia-Pacific mangrove forest, but very few have been developed commercially because of lack of knowledge of the product, of marketing, of storage, and so there are major challenges to be found at all levels along the value chain for development of these products. So this is a big challenge to us as researchers in order to investigate where the bottlenecks are and solve the bottlenecks so that we can effectuate a sustainable transformation. And the final point is that if you look at the complexities of the value chain and all the factors that impinge upon them, both supporting and enabling factors and constraints, these all need to be developed in unison in order to achieve successful product development for as a basis for viable livelihoods. Thank you.
Thank you, Dolphy. So that were our presentations from our researchers. Now we will move out into the breakout rooms where we went a little bit over time. So we have 2 times 10 minutes to discuss about the different presentations you saw. You can ask questions to the speakers. So how to get to the breakout rooms? You should press the button below that says return. It has a little blue round, and then you will return to the main page of Hopin. And then on the left side, you will see sessions. So if you click sessions and scroll down, you can see the different researchers in the different breakout rooms, and you can join any one of them you want. And after 10 minutes, you should switch and go to another researcher, so you can talk to 2 or 3 different researchers if you want, and ask questions to them. So yeah, I see you in the breakout rooms, and after the breakout rooms in about 40 minutes or 20 minutes, sorry, we come back here and do a last round of key discussion points. Thank you, and I'll see you in the breakout rooms. Yes, we're back.
Ja, en weet je wat er dus ook gebeurt? Is dat je zet eerst...
Sorry, Pepijn, everyone can hear us now, and we are back in the main stage. So.
Okay. I'm seeing only you and myself.
Yes, that's correct. The rest still has to come back from the main, from the breakout rooms into the main stage again. There's Sander. Welcome back to the main stage.
Welcome.
So we have 5 minutes left of the presentation. Were you able to talk about some things in your breakout rooms?
No, I had no visitors.
Oh, that's a shame. Sander?
Yeah, we did discuss the development of new seaweed-based food products and how that they should how to make them attractive, but also how to make them safe for consumption.
Great. Let's see, I will try to get the others back. Oh. I think the breakout rooms have been closed now. So the others should come back here. Well, welcome back to the main stage. Did you have a nice talk with some of the people in the breakout rooms?
I have this talk with Alam.
I didn't find anybody in my room, so I had a good talk with Siri about our project. And
Good. And I saw Peter van der Heijden was in your room, Bushri.
Yeah,
Welcome back, Dr. Anita.
I'm here.
Did you say something, Romy?
Sorry, yeah, did you? I saw that Peter van der Heijden or no? Jan, was he in your room? You were talking.
Jan is in my room.
Oh, sorry.
Yeah.
So what did you talk about?
Because Jan have a project with the PP, so we discuss our project, and also we discuss with my topic as well. Just it's not much discussion.
Okay. Yeah. Well, thank you so much, everyone, for your great presentations and our work. And I hope that people watching this really enjoy the presentations and have a little bit of a think about the different ways we should approach food systems and sustainability in aquaculture in Indonesia and Asia.
Yeah.
Low trophic food systems. So seaweed, mussels, mangroves.
Yeah.
Well, thank you all so much. And I think, you can get an e-certificate. I think the people from Winner posted a link on that. So if you want an e-certificate, you can find a link in the chat box.
Yeah, yeah.
And if there's any questions, you can always put them in the Q&A.
Yeah. Okay. Thank you, Romy. Thank you for leading us, in the discussion. It's just great. Yeah. Okay.
Thank you all for presenting.
Guys.
Terima kasih.
Terima kasih. Bye.